Section 4.2, the addition rule and the rule of complements. Example 1. The table presents the numbers of U.S. workers in thousands categorized by type of occupation and educational level. A. What is the probability that a randomly selected worker is a college graduate? Okay, the first thing we ought to do is get the sums over here to the side of each one of these rows. So 17,564 plus 31,103 is 48,667. And you can see I've added this row together, and then this row, and this row, and this row. And then this sum down here is the sum of this column. This sum is the sum of the college graduate column, and this sum right here is the sum of the non-college graduate column. Now we are asked to find the probability that a randomly selected worker is in fact a college graduate. So we are looking for the probability of a college graduate. And that is going to be equal to all of the college graduates right here, 43,181, divided by all the people in our sample right here, 126,172. And if we put that in the calculator to get the decimal approximation out to 3 decimal places, we get 0.342. B. What is the probability that the occupation of a randomly selected worker is categorized as either sales and office or as production and transportation? Okay, so we are looking for the probability of sales and office or production and transportation. Now this should be equal to the probability of the sales and office plus the probability of production and transportation. And there won't be any people in the overlap there. There won't be any people who are in sales and office that are also in production and transportation. So there's nothing back here to subtract off. Alright, so the probability of sales and office is going to be all of our sales and office people, and they are right here, 29,704. Out of everybody in the sample, 126,172, plus all of our production and transportation people, they're right here, 15,905. Divided by everybody in our sample, 126,172, and that will give us 45,609 over 126,172. And when we put that in the calculator for a decimal approximation out to 3 decimal places, we get 0.361. C. What is the probability that a randomly selected worker is either a college graduate or has a service occupation? Alright, so this time we want the probability of a service occupation or college grad. Alright. This is going to be the probability of service plus the probability of a college grad and this time we will have to subtract off all the people who are in service and a college grad at the same time. Okay, and the reason is because all of our college graduates are going to be adding this column right here, or a total down there at the bottom, And our service occupations are going to be adding this row right here, or this total out here to the side. And you'll notice that right here in this area, this number 2,385 is used in both of those probabilities because it's included in the college graduate column and also in the service column. So the probability of being in a service occupation is 18,352 divided by 126,172 plus the college graduates 43,181 divided by 126,172, and then we're going to subtract 2,385 over 126,172, and that will give us a grand total of 59,148 divided by 126,172, and when we put that in the calculator to get the 3 decimal approximation for it, we get 0.469. Example 2. A college student is chosen at random. Event A is that the student is older than 21 years, and event B is that the student is taking a statistics class. Alright, so event A, the student is older than 21, and event B, the student is taking a statistics class, and we're trying to decide if these events are mutually exclusive. In other words, if one of them happens, does it make it impossible for the other one to happen? If you are 21, is it impossible for you to take a statistics class? Or, if you're taking a statistics class, is it impossible for you to be older than 21? No, neither one of those are impossible. So these events are not mutually exclusive. Example 3. A college student is chosen at random. Event A is that the student is an only child. And event B is that the student has a brother. Are events A and B mutually exclusive? Does the occurrence of one of the events make it impossible for another one to happen? Is it impossible for somebody who's an only child to have a brother? Or is it impossible for somebody who has a brother to be an only child? Well, if we ignore all the plot twists and whatnot you can find in the movies or in TV shows these days, these events actually are mutually exclusive. You cannot be an only child and at the same time have a brother. So these are mutually exclusive. Example 4. In a statistics class of 45 students, 11 got a final grade of A, 22 got a final grade of B, and 8 got a final grade of C. A. What is the probability that a randomly chosen student got an A or a B? Well, these events are mutually exclusive because you cannot get a final grade of an A and also a final grade of a B at the same time. So we're looking for the probability of an A or a B, which should be the probability of getting an A plus the probability of getting a B. And since they're mutually exclusive, there will not be any overlap here. So the probability of getting an A, well, 11 students got an A, so this is going to be 11 out of the whole class, which was 45, plus, then we have 22 who got a B, so the probability of getting a B is 22 out of the whole class of 45. And when we add these together, we get 33 out of 45. And when we put this into the calculator to get the 3 decimal point approximation, we will get 0.733. B. What is the probability that a randomly chosen student got an A or a B or a C? This time, we are looking for the probability of A or B or C. And again, these events are going to be mutually exclusive because you can't have a final grade of an A and at the same time have a final grade of a B or a C. So we're going to find the probability of getting an A, add it to the probability of getting a B, and add that to the probability of getting a C. Now the probability for getting an A, we've already said, was 11 out of 45. And the probability for getting a B, we've already said, was 22 out of 45. So the probability for getting a C, well, up here it tells me that 8 people got a C. So that's going to be 8 out of the class of 45 students. And when we add these together, this is going to give us 41 out of 45. And when we put this in the calculator to get our 3 decimal approximation, we will get 0.911.